All right, today is an exciting topic. This is something I really like. It's pathfinding. And in Spacefaring Adventure, I've decided there's going to be things to find paths around. Otherwise, the combat would be really boring. So, ships are going to be able to generate shields. They're like these just impenetrable barriers that you then have to fly around. And I used a similar thing in a previous game I made, and it worked really, really well. So, with that, I need to make a pathfinding system. And it's actually very interesting in this situation because my game is not grid-based. And the environments, because the characters are creating the walls, I basically need a system that is able to adapt to a dynamic environment. So I set out to create something, and it's a lot of content I want to cover. So I decided to split this into two videos. This one is before I've actually implemented the algorithm, and I'll just go over how I came up with it and what goes into coming up with something like this. And then the next one will probably be in a week or two. It's probably more like 2 weeks, but it's going to be hopefully after I've implemented it and I can show it to you guys in action and do some stress tests like making tons of convoluted walls and just see how far we can take things. So I like to visualize things and make nice diagrams. It just makes my brain have an easier time wrapping my head around it. And when you look at other pathfinding systems like A-star or Dijkstra's algorithm, they're all either node-based or grid-based, but they're kind of the same thing because grids are just nicely uniformly adjacent nodes. So, and what I mean by node-based is that there are invisible objects like you see here, I've numbered them all, that we raycast against to see if there's objects in the way, to see if there's a path. So if you do a raycast from 4 to 3 and we don't hit anything, that means there's a free, open space between those two nodes. And the algorithm basically just is designed to return a list of nodes that the AI character will travel to in order. So the system has to be dynamic, and when you make a pathfinding algorithm, there always has to be some assumption the algorithm can make to actually make it possible. And grid-based is one of the oldest and most classic assumptions. If you can assume that everything is aligned to a grid, and some tiles on the grid are passable and others are impassable, well, pathfinding is a solved problem. A-star works great. There's variants of A-star that check from both your target location and your current location at the same time, and they're pretty efficient. And you can take a similar algorithm and apply it to nodes. Like I had a game where I had lots of freeform objects just kind of placed haphazardly, but the environments were static. So I could place nodes and have the nodes raycast to each other and build paths between each other. So if a character had to go from one node to another, it simply just looked up the path. And I could cache them all beforehand because the environments didn't move. And so it was basically free. You need a path, just look it up. There's no calculation going on. Unfortunately with this, that's not possible. So I've taken what I've learned in previous projects and brought it into here. And I'm going to go through it step by step, and if you find it boring, feel free to turn it off, because this could get pretty dry. I'll try to make it interesting, though. So the question is, what assumption can I make about this game? And I have decided that all barriers are going to be rectangular, which is a pretty good assumption, because even if an object isn't rectangular, like if I have this ellipse, it still has a bounding box. Like you can see the selection box around it. Unity has a bounding box around everything. It's not ideal to use the bounding box though, because you can see when I rotate this, the bounding box is now nowhere near representative of the shape. So I'm using the colliders, rectangular colliders, which is good because you can put a rectangular collider on any shape, and it treats it like it should. So even if the collider was a trigger, it would still work properly with the pathfinding system. So with all that out of the way, what the heck is going on here? I've got this simple situation. I have these two barriers kind of really transparent because they're not important right now. And this is our AI player. Let's go like this and go AI. That's a really fat font. Okay. And then we will group these. Okay, and there's the AI's target. So step 1, do a raycast to the target. So let's use this tool. What did we hit? We hit yellow object. Yellow object is in the way. So we then learn about all of yellow object's nodes. So we add them to master node list. So we know what object 1, or node 1, 2, 3, and 4. Awesome. Then we take all the nodes in here, or the nodes we just learned about, and we see if either the AI or the AI's target has direct line of sight to any of them. So AI looks at these 4 nodes and says, can I see any of them directly? And in fact, we can see 4. We might actually be able to see 3 too. Let's see if we do this. Nope, not quite. So we can see node 4. We add that to reachable nodes. And the target can see none of them. It tries raycasting and hits other objects, but we just ignore that for now. We say, nope, they're not reachable. All right. So far, so good. We have found an object and found a node. So we have a lead as to which direction we can go around this object. So current node equals 4. And then we add our current node to the path. All right. Next time through the loop, we're in a different state. We say, are there any nodes that we can see that have not been visited? So this looks at these nodes and says, yep, this one. We can go to 3. Great. Let's add 3 to reachable nodes. Let's make our current node 3. And our path is now 4, 3. It's not complete yet. Now something cool is going to happen. Now we go through the loop again. Current node is now 3. And we say, are there any unvisited nodes that we can see? And there are none. We visited 4, and we can't see 1 or 2. So in that case, we simply do a raycast to our target again. And what happens when we do that? Well, we discover blue. So I'll bring blue all the way up in opacity. We do a raycast. We say, hey, blue is in our way. That's 4 new nodes. And that's one of the benefits of assuming the rectangles. You know there's always 4 nodes. So we're going to add 5, 6, 7, and 8 to our master node list. 5, 6, 7, 8. Great. Now, we kind of start at the beginning again. Every time we discover a new object, we say, hey, can our AI or our target see any of these new nodes? And AI can actually see one. It's 8 right here, which might screw things up, but we'll see. So we can now reach 8, and our target can actually see 5. It's pretty great. And every time we add things to both of these lists, we do a check. We check for a common element. So if we had 5 in both of these lists, we would know we've got a path. Because they can both have access to the same node, that means there is a path. But there's still no common element, so there's no path. But what we do have now are new nodes that are visible and unvisited. So we go through the loop again. We say, can 3, which is still our current node, see any new unvisited adjacent nodes? And yes, we can see 6. So 6 gets added to our reachable nodes. Current node becomes 6. And 6 gets added to our path. All right. Then we loop again. This is the main loop of our algorithm, just moving from one node to an adjacent node. And we say, hey, are there any new unvisited nodes in master list? And we, yeah, 5. Okay, let's add 5 to reachable nodes. And at that point, it just stops. Because every time through the loop, we're checking for common elements. And it is, whoa, we have a common element. And this list only ever contains the nodes that have a direct line of sight to our target. So we know as soon as we have a common element, our algorithm is done. It's really great. And we can also assume it was the last node we added. So we say current node is 5, a little bit unnecessary, but the algorithm will do it anyways. And we add that to our path. Our path is done. It is 4, 3, 6, 5. And as soon as the AI has a direct line of sight to the player, we just ignore the pathfinding altogether. And then I do a kind of a clever trick. I actually reverse the order of the list. So 5, 6, 3, 4. And then we loop through these nodes and we travel to them in this priority. So we say, can we see 5? Nope. Can we see 6? Nope. Can we see 3? Nope. Can we see 4? Okay, let's move to 4. And as we go this way, we get to about here, and then we see 3. So it's going to say, do we see 5? Nope. Do we see 6? Nope. Do we see 3? Yep. And so we completely abandon the 4th node because it's no longer necessary, and we just beeline it for 3 till we get about here, and then we can see 6. So we just move to 6, and about there we can now see 5, so it goes this way, and out there we can see our target. So it cuts all the corners just perfectly. And it's a physics object, and things are going to be moving with forces, so things aren't going to move and change direction instantly. So it's kind of going to just smooth things out a bit to about there. And you can see it actually calculated the perfect shortest path. And that is pathfinding in a nutshell. This pathfinding. I've tried it on a bunch of different scenarios. One that seems to break it is if I have 2 objects like parallel like this, because then this guy moves around. When there's 2 nodes visible to start with, he just goes to the closest one. So you go 6, and then 5, and then 7, and then 8, and then you completely run out of nodes, so it thinks there's no path. So there's 2 solutions I have to that. When you run out of nodes, then just do a raycast to the target and get the new object in the way, or do a line cast and just learn about every object in the way and add all of these to master list. I don't know, I got to figure it out. It just requires me to implement it and see what works, what doesn't, and then somehow prove that it will work in every situation, which is kind of a scary prospect. So I hope that wasn't too convoluted. Go ahead and ask any questions. I just made this up. And and it might be dumb. We will see in a couple weeks, hopefully. All right. See you later.